Okay, my favorite problem out of this set. Anyway, we're here at GoToMath.com. Applications involving linear equations, 8.2. Looks like Cody Keys. If you don't know who he is, well, you probably will at some point in time in the future. And his best friend, Mad Mike. Wonder who that is. Went for a foot race at high noon. They are to race at a constant speed from start to finish. So we got to throw this in here to simplify the problem down. Okay, just to let you know. All right, the two runners had a run time difference of 3 minutes after reaching the finish line. If you don't understand that, I'll explain it here in a minute. Cody was known to be running at a constant rate of 6 miles per hour. So this constant rate, in other words, I know it's not even possible, but just go with me on that. And Mad Mike had a run rate of 4 miles per hour, and it was constant also. What was the distance of the race? I find this kind of a fascinating problem. What was the distance? In other words, how far from the start line to the finish line, right? How far were they racing? Okay. This time difference is, in other words, Cody came in. All right, and then 3 minutes later, Mike came in, Mad Mike. All right, so that's what we mean by that. Okay, so try to work this problem out. Good luck, and if you can't figure it out, well, just watch the rest of the video, I guess. All right. Okay, over at the drawing board. So we have... we'll just draw a picture here. So we'll say that this is where they start, and then this is the finish line here. Okay, and we're going to make both these guys red for a reason. All right. So we'll say this is Mad Mike. Says, got his hands up in the air. Cody, wait for me. Yay. And then this is Cody. Cody, I'm giving you the benefit of the doubt here on this race. He's got his hands out. I'm going to win. Alright, so Cody comes over the finish line, and then 3 minutes later, here comes Mike. And the question is, how far did they run? Okay, so that would be the distance. That would be this distance here. How far did they run? Okay, the distance. I shouldn't have put arrows on that. I don't know why I did, but anyway. Alright, so there's one model that we need to know, and that is the relationship between distance and rate, and that's going to be distance is equal to, remember, rate times time. So this is what we're going to be using. The distance is equal to rate times time. Okay? So the distance of Cody, we'll call this d of c, is equal to, now we set up here that Cody's rate was 6 miles per hour. Okay, and we don't know how long it took Cody, but we'll just call it t. And then we have the distance of Mike is equal to, and his rate is 4, and we don't know how long it took Mike. So I should say this is T of C, and we'll call this T of M. But we do know that the difference is 3 meters. So we could actually, or 3 meters, 3 minutes, we could actually write T of C, or T of M, I guess, in terms of T of C. If we wanted to do that. In other words, T of M is going to be T of C plus 3 minutes. Now, there's something I need to note here, that this stuff is in miles per hour, and I think what we're going to do here is we've got minutes, and we're just going to convert this minutes here into miles per hour, and so that would be 3 over 60, right? So that would be in miles per hour right here. 3 over 60 is in miles per hour. Makes sense. Okay, so we can actually rewrite d of m now as 4 times T of C plus and this actually will reduce down to, I want to reduce that down to 1 over 20, I guess. Okay, so remember, that'll get you, that kind of stuff will get you minutes and miles per hour. Alright, since this is miles per hour, we need our time in miles per hour also. Okay, now the deal is they're both running the same distance, so that means that this d of c is equal to the distance that Mike runs. You see that? So now what we basically have is we'll have an equation that involves only one variable. Plus 1 over 20. Okay, the time that it took Cody plus the additional 3 minutes. Right, that gives us, well, anyway, I've already talked about that. So now we have an equation that involves only one variable, and all we have to do is solve for t of c. And then this ends up being 4 over 20, which will actually reduce down. We'll do that here in a second. Okay, so we'll go ahead and take the 4t of c over to the left, and that reduces down to what, 1/5, right? Okay, so this becomes 2t of c is equal to 1/5, and t of c is equal to 1/10. Now remember, this is in hours, so we'll say hours right here. We don't remember this is 1/10 of an hour. Okay, 1/10 of an hour. Let's go ahead and rewrite this up over here. Let's make that a different color. All right, I'm going to rewrite this. 1/10 of an hour, which is actually, what is 1/10 of an hour? That's 6 minutes. That sound right? 1/10 of an hour is 6 minutes, right? Or 0.60. No. 1/10. Yeah, times that by 60 minutes. Be 6 minutes. Okay, so that is the time that it took. Now remember, we're wanting to know the distance, and so we're going to do 6 miles per hour. We're going to go ahead and use that number, and that is 0.6 hours. 0.6 hours. If we wanted to convert that to minutes, well, we get yeah, that would be hours. The distance. What am I thinking? I'm not thinking. This distance. Right, so this is in hours, this is miles per hour, so this would be miles. We did this in miles, right? Yeah. So this ends up being miles. So for some reason they ran a race at 0.6 miles. That's what we were actually looking for. And of course, 1/10 of an hour is is, if you wanted to convert that into minutes, right? It'd be 6 minutes. You ran it in 6 minutes, and I guess Mike would have ran it in 9 minutes. Yeah, something like that. Anyway, but this is what we were looking for right here. Okay, interesting problem. One I just actually came up with. I saw a model about doing calculating earthquakes and find the distance to the epicenter, and I converted it over to this problem here, which I find this whole lot more interesting. Alright, so there it is. We're over here at GoToMath.com.